For this video, we're going to go over cation and anion radii, right? The sizes of these cations versus anions. So, an anion will gain electrons. More than one, doesn't matter, right? We're not sure just yet. So, let's do an example. How about oxygen versus O2 minus. O2 minus is the normal, it's the predicted charge of oxygen, right? It's oxide. So oxygen has, let's consult our periodic table. Oxygen has 8 protons. So it also has 8 electrons, right? O2 minus has the same number of protons, but how many electrons does it have? It has 10 electrons. So let's think about this for a second. They have the same number of positive in the middle, pulling on 8 electrons, and this one's pulling on 10 electrons. Which one is going to have a less strong grasp, right? 8 protons, 8 positive charges pulling on 10 negative charges, that's not going to have as tight of a hold. So I believe on Mastering Chemistry, we have number, oh fudge, I had it a minute ago. This is actually one of the questions on there. So the effective nuclear charge on here is actually going to be smaller. We have the same amount of shielding, but we have more electrons that we have to pay attention to, right? More electrons that we have to rein in. So if we have 8 protons pulling on 8 electrons, that's a certain pull. But over here we have 8 protons trying to rein in 10 electrons. So they're going to have to spread out their attraction to 10 electrons. So this is going to have a larger radius than the neutral element. Let's talk about an example. How about where a cation? Cations, they lose electrons, right? So let's think of an example for that. How about Mg and Mg2+. Magnesium has 12 protons. If it's neutral and has no charge, it must have 12 electrons as well. Over here, it must have 12 protons because it's the same element. How many electrons do we have over here? We have 10 electrons. So it just so happens that 12 protons are pulling on 12 electrons, so they have this certain attraction. Over here we have 12 protons pulling on only 10 electrons. So they can spread out their attraction even more to these 10 electrons. So this is actually going to be a smaller radius. So cations will have a smaller radius than the neutral element, than the neutral atom, and anions will always have a larger radius than the neutral ion. Now let's go into this. It looks like these are isoelectronic, right? So let's do one additional challenge here where we have the radius of oxide versus Mg2+. So the things we have to consider here are we have 8 protons pulling on 10 electrons. Over here for magnesium we have 12 protons pulling on 10 electrons. So let's use the same. So these are isoelectronic, like from the other video. So that means that the electrons are the exact same. What's the only difference? Protons. So picture it, if you had 8 magnets pulling on 10, or you had 12 magnets pulling on 10, like something 12, an attraction of 12, 12 pulling in on 10 versus 8 pulling in on 10. This is going to be smaller. Why? Because we have this is going to be smaller because we have a higher effective nuclear charge pulling on the same electrons. We have a smaller effective nuclear charge pulling on the same electrons. So this is going to have a smaller radius than this. So the radius would look like that, right? Bigger, smaller. So in this example, there's I looked at the master in chemistry. There's quite a few questions that have us put them in order. But if you identify that they're isoelectronic, the ion that has the most protons is going to have the smallest radius. The ion that has the least number of protons will have the least pull, the lower number of effective nuclear charge, so it will not be able to pull on those electrons as tightly, so the radius is going to be bigger. I hope this helped out, guys.